So good afternoon, everyone. I'm Tom, this is Meg, this is Jess, this is Kaicheng, and we are the OpenSidewalks team. So I want to start with a problem that we're all probably familiar with. Cities can be incredibly complex to navigate. It's a problem I feel acutely. I've got a bit of an accent, and asking for directions can be an unpleasant experience for absolutely everybody. So it's fair to say that I would be truly lost if it wasn't for Google Maps. But let's challenge this notion that navigation is a solved problem. And I want to share the story of Kevin with you here today. So Kevin is an individual with limited mobility who uses a wheelchair. He says, using a tool like directions on Google Maps doesn't really help me get around. Actually, sometimes this does more harm than good. I'm sent down streets I can't cross or up inclines that are impossible to climb. It can be deeply frustrating. The key takeaway here is that we forget about the sidewalk when we're creating these maps, and it's got big consequences for someone with limited mobility. Kevin's also part of a really big community. In fact, if we include all the people who have difficulty walking more than a quarter mile in the States, there are 54.5 million people who would benefit from better sidewalk data. But we can also relate this problem to everyone in the room. If we had more data on the sidewalk, we could enable all sorts of custom wayfinding to get around the city. We can all dream of a future where I could get custom directions on how to walk my 10 puppies at the touch of a button. So we have this compelling opportunity, but there's a couple of questions. Where are we going to get all this sidewalk data, and what map are we actually going to add it to? And this is where the hero of our story comes in, OpenStreetMap. Quick show of hands, who's familiar with OpenStreetMap? So most of the room, so I can go through this real quick. So as you all know, OpenStreetMap are basically the Wikipedia of the mapping community, right? They're built up from individual contributions, and like Wikipedia, they become a trusted resource that individuals, companies, and more recently, even governments are starting to use to rely on for their mapping needs. So it's this high quality resource that we can trust. The incredible thing about OpenStreetMap is that it was built from over 1 million different individual contributions, and they constructed this map that makes sense using this common language on how to describe the world. That's a pretty incredible feature. So we've given enough detail to justify the statement as to why OpenStreetMap can be the hero of this story, and there's 3 points I want to highlight. They have this high quality, up-to-date map that we can use to give people directions. Secondly, they let people actually contribute information to the map, so there may be a pathway forward for us to add this sidewalk data. Thirdly, they publish all information in the map under an open data license. This is really important, because it means that if we do manage to get the sidewalk data into the map, we're able to then extract it and use it to create really useful tools, such as a routing app that would help Kevin get around the city. So this was our strategy to set out to kind of implement this project and convince OSM community of this opportunity this summer. We had 3 primary objectives: to review how current practices were meeting pedestrian needs, to design and implement a sidewalk schema that would better capture pedestrian information based on this analysis, and then finally to actually create the pathways for adding sidewalk data to OSM so that we could quickly get to scale and create useful tools. So starting with the first. Well, we remember from Kevin's story that there were a couple of pieces of information that were really important to work out how to get around the city. Obviously, knowing about the sidewalk was one, but another was knowing where to cross the road safely. So that includes curb cut information and knowing where the marked crossings are. Well, if we actually look at coverage within OpenStreetMap, it's clearly insufficient to actually do anything useful, for example, for Kevin. This is a visualization that shows the current coverage of sidewalk data in the city of Seattle, and it's certainly not enough for any kind of useful routing tools. It gets worse for crossing information. And if we look at curb cut information, it seems the only place where you know where the curbs are is the University of Washington campus, which is great for all of the students here today. So why is this? Well, we might ask a question by starting to examine what is the process that a user actually has to go through in OpenStreetMap to contribute pedestrian information to the map. And for anyone who has used the ID editor, which is one of the most common ways of adding data to the map, this is a really familiar view. It's really simple to work out how to use this. You're basically given aerial imagery and some simple tools that we can see in the top left of the image, which you can interact with to contribute data to the map. For anyone who's ever used a computer, it's pretty straightforward to work out what to do next. For example, if I wanted to add these roads that I see here in the image, it's real simple. I would just use the line tool, and I would click and draw them in. There's two key points. It's easy for the user and it's to work out what to do. And secondly, it's easy to spot what areas of the map haven't been covered yet. Well, how do we think this process extends for sidewalks? We might think that we would just click and use the line tool again, right? But it's actually extremely convoluted. And actually, to add sidewalk data, you first click into the middle of a road if it's already been added. And only then can you add sidewalk data basically as the metadata of the road. That's not an intuitive process. And secondly, it's hard for the user to figure out where they need to be contributing to improve the coverage in the map. And that's perhaps an explanation for why sidewalk data coverage is so bad, as we saw within that visualization. So I'm now going to pass over to Jess, who will explain our strategy to tackle that problem.
So Tom explained pretty clearly the holes in pedestrian data available in OpenStreetMap, but this isn't a problem only with OpenStreetMap. Google, Bing, Yahoo, none of these people have adequately captured the sidewalk and pedestrian information that Kevin would need to navigate the city. But OSM is the only open source mapping solution that we can kind of contribute to and rectify this problem. So how do we do that? We need to keep it simple to keep people engaged and encourage mapping. So how do we do that? We draw sidewalks as lines, we draw crossings as lines, and we draw curb cuts as points. It's minimal changes to the way OpenStreetMap works now, and it's easy for people to understand. As we can see here, capturing pedestrian data in this way is much more representative of the built environment that we experience. And this more straightforward approach encourages user contribution because it's easier to understand. It's also easier for routing algorithms. And it facilitates maintenance of the map moving forward. As an open source project, keeping this data good is important. So once we had decided on this kind of way of representing our data, it was time to engage with the OpenStreetmap community. And this is no small task. There's millions of users, and we engaged in conversations online with the listservs and forums. We were lucky enough to present our work and our kind of schema for capturing sidewalk data at the State of the Map conference. And we got a lot of great feedback from people also interested in pedestrian mapping and the issues associated with that. So great, we figured out that we need to draw some lines and some points, and we've talked to a lot of people, but how do we move forward? How do we make this map look like this? Because a map without data isn't very useful. Fortunately, municipalities all around the country have been opening up their data sets, and a lot of these municipalities have that sidewalk, curb cut, and crosswalk information that we need to make a usable map. However, it's not as easy as just dumping all of this municipal data into the OpenStreetMap. A lack of data is one issue, but messy data is another. You don't want your map to look like this. The blue lines represent sidewalks. They are running into each other. They're not meeting up. They're ending in the middle of the road. Cleaning of the data is critically important. So kind of part of we have some back-end solutions to cleaning, but they don't take us the whole way. What we really need is a step with human verification. And this is also critically important to the OpenStreetMap process, which requires human verification for all of their data imports. So figuring out this import workflow was a whole large task for us. Basically, once we have the open data, we have a few scripts and tools that we've created to clean the data and get it ready. Then we have to facilitate this human verification, and then, only then, after it's been verified, it can go into OSM. So we created 3 tools to prepare the data prior to being human verified. First, we divide the big Seattle data sets into chunks that are more manageable for people to kind of take on when they're verifying. Next, we merge the sidewalks, crossing, and curb cuts for a similar reason. This way we were eliminating as much as possible duplicate data and making it easier to verify. And then we need to convert this into a form that works for OSM. For the next step, for the human verification step, we modified a tool that had been developed actually for humanitarian mapping purposes with OSM, the OSM Tasking Manager, and this allows people to go online and see kind of the different sections that we chunked in the previous step and choose one of those sections and work on that and verify it. The small chain sets are kind of what OSM prefers, and it makes it easier to track what's been verified and what's not. So this is one way that user contribution human mapping has been important in our project, but there are other reasons we've really needed to pull people in, including filling in gaps where data doesn't exist, and for maintenance moving forward. We need people eyes on this. So Kaicheng is now going to tell you about some of the other human-oriented pieces of this project.
So, while importing can bring a large amount of data into OSM at once, each import dataset must be cleared with OSM community through the import proposal process. So OSM cares about getting more people mapping. As an open source project, user contribution is critical to creating and maintaining. The community standard for mapping is a manual annotation. Additionally, since imported data will never be complete or perfect, manual mapping is required to ensure that imported data is maintainable. This effort needs to engage super users with years of experience, as well as people seeing OSM for the first time. So tools for manual mapping serve the community in a number of ways and are critical to components for supporting the addition of Sidewalk data to OSM. On August 7th, we have run a mapathon on UW campus. Mapathons are workshops that people in OSM communities gather around to do mapping for the map. These events can also strengthen community ties. Our mapathon in specific is to map sidewalks, curb ramps, and crossing on campus, with the focus on accessibility. 36 people attended the mapathon, and almost half of them are newcomers to OSM. The following diagram describes the data workflow for our mapathon, and these tools may also be used by any mapping enthusiast to expand the pedestrian data in OSM. With few mappings, aerial images, and mobile app in place, we have 3 data sources in total for manual mapping. Field mappings and aerial images entries are fitted into customized ID editors, and the mobile app entries are fitted into our private data storage. And finally, all these entries will be submitted to OSM to make them available to the public. The ID editor is a web interface which allows users to draw rows features from aerial images and upload it to OSM directly. We modified the original ID editors to simplify adding pedestrian data using our schema. So compared to the general one, our custom editors leaves unrelated presets out, but includes additional presets we need. It makes things easy for new users to contribute to sidewalks mapping, while reinforcing our sidewalk tagging scheme. And as a device which is becoming more and more important in people's life, we also want to make smartphones into a way for people to make contribution. Therefore, we made a data contribution app for mobile users as well. The app is able to mark sidewalks, curb ramps, and crossings, and upload entries to our private server. Comparing to other generic mobile editors for OSM, our app only displays options that are specified in our schema, without extra properties which might lead to confusion while doing mapping. Also, there are already numbers of accessibility features available both on Android and iOS. In order to engage more different groups of people, we also made an effort to improve the app so it works with these features. Through this mapathon, we were able to contribute a significant amount of pedestrian data to OSM. This screenshot shows edits submitted during the mapathon event. But we also have additional complete field mapping that is still need to be digitally added. And for maintainability, all these tools mentioned above are on GitHub under OpenSidewalks. General README and comments are included in source code. So when this program ends, the next group of people can still reuse them and continue on this project. And more mapathons will be held in the future. Please stay tuned. Next, I will turn it over to Meg so that she can give a summary to our project.
So hopefully by now we have convinced you of what we learned in our original review stage, which is that pedestrian needs are not being met adequately by current map solutions, including OpenStreetMap, and in particular, mapping solutions for people with limited mobility need to be radically improved. So based on that initial exploration, we designed and implemented a sidewalk schema, which we've proposed and discussed via OSM listservs and at State of the Map. We've also worked toward building pathways to making it easier to import that data. So that included our import stages, in addition to the data wrangling tools that we created ourselves. We've modified this OSM tasking manager to suit our project and include sidewalk data that can be imported. We've also created tools for manually mapping, including the iOS app for user contribution and a modification of the ID editor so that Sidewalk Edition is easier and more straightforward for new users. Throughout this process, we've also been engaging with OSM through additional mailing lists and State of the Map because stakeholder engagement has been critical for this project. And they'll be ultimately the community who's carrying it forward. However, we are very fortunate that we have partners in our local community who are already committed to carrying it forward, including Access Map Seattle, which is an example of a downstream application that could take our data for annotated sidewalk information and immediately use it for accessible mapping. They already have strong relationships with disability advocacy groups in the city of Seattle and a working application in testing. The Taskar Center for Accessible Technology also has individuals who are committed to carrying this project forward and working on these tools as they progress. TriMet in Portland is already using OSM data for their mapping in the city and is very interested in similar projects, which is why we've highlighted and prioritized making a reproducible workflow for annotating sidewalk data. And King County Metro and Urban at UW are also invested in this project. We'd like to thank all of our sponsors who supported this work, and special thanks to Clifford Snow and Chase Stevens of OSM Seattle for working with us so closely. And thank you so much for your attention and interest in our project. You can find more information about our project at opensidewalks.com. All of our tools are available and will be completely documented by tomorrow on GitHub. There's a lot of documentation already in place. You can also follow us on Twitter at OpenSidewalks. And with that, I'd like to answer any questions that you may have at this time.
We saw that some of the Seattle sidewalk data, has a lot of inaccuracies and sort of path crossings and everything. Have there been any experiments, or is there opportunity to do image analysis on aerial photography to do matching of sidewalks to roads, or maybe path fitting to the more rich and accurate road data? Use that to clean out some of the data?
That wasn't an experiment in our group, but that was actually the screenshot that you saw was actually already partially pre-processed by some of these tools. So it's still messy even after that, but I'm not sure what pre-processing, I don't think they were aligning with aerial imagery when they did that pre-processing, but I think the point of the outcomes of what we discussed with OSM is that ultimately it needs to be human verified. So whatever pre-processing we have in place, we really need to create these tools that make it easier for users to engage with it. Cool. But there's definitely opportunity for better automated import as well.
Throughout the system, yeah.
Right.
That was a very complicated part though.
Yes.
From the group
yes. Yeah.
Was there reliable slope data? I didn't see too much slope stuff, but it seems like municipal data should have elevation at every intersection or something that you could interpret.
The slope data actually comes from a US Geological Survey, and Access Map has that information. They have it at a block level currently, and it's difficult. It's not entirely straightforward to add it in OSM in a way that is maintainable. There are tags for incline, but for example, if the segments don't match up with the segments of information that are available, it's not totally straightforward. And so we're also interested, and I believe the Taskar Center is doing some work in collecting that information in a more automated way.
How limited is this to Seattle at this current position? Like people can do it about different cities?
Did you say how limited is our process to Seattle? So it's limited in the sense that every import through OSM, every new data set has to be cleared with the community and go through an import proposal process. The tools are widely applicable to other cities. They're using standard formats, GeoJSON, converting to the OSM format, which is standard, and all of our other the ID editor is, of course, widely usable for any situation. It's actually already applicable to other locations. But for the import process specifically, there has to be community engagement locally to know that it's a good data source and that there will be people who are responsible for the maintenance and the chunking of the import so that there aren't, because they've had previously really negative experiences with imports, they don't want to have a massive import, a giant change set that has to be reverted later because they have to maintain that history forever.
Was there any consideration for type or class, like quality of the sidewalk?
Do you mean something like surface or?
Well, I mean, that's specific, some with limited mobility, yes, surface or width of the sidewalk.
Yes, we include those tags as presets in our ID editor, and we encourage people to map them. It tends to be a thing, so surface especially tends to be something that people only notice if it is inaccessible. So we don't have uniform mapping of surfaces, especially in places where it has been manually annotated. In the import data, that information is already there automatically. Yes?
Did you do any work on, as far as routing for directions, like for if someone has a wheelchair or if, you know, limited mobility or for others? Did you do any kind of work on the prioritizing around a bad surface or anything like that? Or do you want to leave that to your partners, like the one you mentioned?
So this project, for this project, routing was out of scope, but it was of deep concern to us in proposing our schema to make sure that it was appropriate and helpful for routing, which is, and it took a lot of consideration because there is not consensus in the community about what appropriate representations there are to make routing more easier. But for our work, we considered that in terms of making the curb cuts especially and the crossings, you can tag them wheelchair yes or no, and that's a preset in our ID editor. And you can also annotate surface if you can go into that level of detail and width. Yeah.
So there's a lot of sort of accessibility and mobility planning and infrastructure investment planning that we can't do right now because of this issue with the data. We can't, if we try to get data out of OSM as you described, it's pretty incomplete. If we go into local jurisdiction GIS files, everything's a mess as you described. We've run into this. So my question is, how quickly can this get done?
Hopefully. So, I mean, it requires really human engagement to get it into the map to make sure it's verified, and I think that's the biggest bottleneck and limiting factor in this work. But we have seen, and we've been informed by our collaborators and colleagues in OSM, that projects with a social impact have the most engagement from the local community, and we saw that with our Mapathon, over half of the participants were new users. And so I think that there is the willingness to commit that time. That's going to be the biggest challenge, I think, or the biggest inhibitor to getting it done, because it requires human eyes, and human time is the most limited here. Yes?
So I'm very new to this. I didn't know what OSM was, so I'm going to say something, and this is already done, or if you already thought about it, please tell me to stop. So first of all, am I right in thinking that, like, when you when you get your Google map or Apple iPhone to show you the traffic condition, that data comes from Apple or Google monitoring the location of your phones. Is that right?
That is my understanding, and Nick is nodding yes.
Okay. So if they can do that, they can also monitor slow movement, like walking. And so if somebody has access to that data, then quite mindlessly, you can do something like what Amazon does, like people like you have walked this route to go from here to there. And then people like you could be defined as different kinds of disabilities.
You could create your own settings.
I'm afraid of the dark, I'm afraid of dogs, and so on.
So definitely, that is of interest, and that's something that our partner, the Taskar Center, is working on as we speak, passive, massive collection of data. I'm not deeply familiar with their work, but you could speak to Anat afterward if you want more details. Yes. Hi. Thanks for coming. This is Chase from OSM Seattle.
What I want to talk about, because this is like a very appropriate time to pitch our meetup group. If you guys could search for I'm sure we'll have another mapathon like this again. So if you're interested in contributing to this, please look for that and sign up, and we'll target it toward you guys.
Yes.
Mark, is this one of the projects you're talking to Evan Olson about?
Yes.
Great, thank you. Question.
Thanks for answering that for us.
Great. Hi, I'm this boss Stan. We want to get you some money.
Okay. Thank you.